Hello everybody, welcome to yet another video by JFB, and in this video I'm gonna simply explain the hexadecimal system. What is the hexadecimal system? The hexadecimal system is just another number system. It's a number system where we're simply using base 16. And if you don't know where these bases are coming from, the typical number system which we use in our everyday lives is called the denary system. And in this system we use base 10. So the main difference between the hexadecimal system and the system we're used to is the bases. Hexadecimal uses base 16 and the denary system uses base 10. This base 10 is also corresponding to the digits we use to represent values. So in the base 10 system we use 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. That's what we use in the denary system. And in base 16, you would imagine yourself, we're supposed to use 16 digits. So we can start from 0 all the way up to 9. Now we get a problem when we reach 10. Should we use 10 to represent numbers? We can't use 10 because 10 is simply composed of 1 and 0, which have already been stated that are also used in this system. So we have to find a way in which to represent this 10 without explicitly writing it as a 10, because we can't use it as it has already been used by 1 and 0. Mathematicians found a way to represent that 10, and it's quite easy. The 10 can be represented by a capital A, the 11 can be represented by a B, and the 12 by a C, and the 13 by a D, and 14 by E. Finally, we have 15, which can be represented by F. So we have digits 0 to 9, which are 10. Then we have 11, 12, 13, 14, 15, 16. Thereby, the number of digits are corresponding to what the base is. We have 16 digits and it's base 16. That's the hexadecimal system. Sorry if I cruise through this. I was trying to rush a little bit so that this video won't be too long. But I hope you understand why we're using this A and not this 10, because 10 is already made up of digits which have already been used, 1 and 0. This 11 is using 1 and 1, which have already been used. 12 is using 1 and 2, which have already been used. 13 is 1 and 3, which have already been used, and you get the point. So we can't use those numbers because they have already been used, unless we can just use other letters to represent those numbers. So that's the hexadecimal system. The main difference is just that we're using base 16, and in the denary system we're using base 10. In your mind right now, if you don't know these systems or you have never even read about this system, you're asking yourself, where is this base 10 even used? I just use my numbers to count every day, 1, 2, 3 up to a million. I count every day without even knowing that there's a base 10. Well, the base 10 is used to show the place value in which that digit is standing. So a typical example I'll show is 213. 213 has 3 place values in which it's standing. So there's a 10 to power 0 here, there's a 10 to power 1 here, and there's a 10 to power 2 where the 2 is standing. So if you say what is 10 power 0, if you know your exponents, this is just a 1. 10 to power 1 is simply a 10, and 10 to power 2 is 100. So you're just increasing the number of zeros. Then you can multiply this 1 times the 3 and you get a 3. 1 times the 10 and you get a 10. 100 times the 2 and you get the 200. That's why when you typically read numbers, you say 213. You don't say 213. If you're reading those numbers, just say 200 because the 2 is standing in 100, and 13 because 13 is standing in 10 and 1. So you add those two numbers together. 3 plus all these zeros is just 3. 1 plus that 0, 1, and 2 plus nothing is 2. Then you get back your number, 213. But in the base 16 system, it's different. There, this 213 would actually be very big. So this would be a 16 power 0. This would be a 16 power 1, 16 power 2. Then instead of multiplying against the tens, 16 power 0 is 1. This is 16. And this is 256. So where you had that 213, it's actually representing a different value in the hexadecimal system, because here we're using base 16. So you can start multiplying 1 times the 3, and this gives you your 3 back. But here you use 16 times 1 and that gives you a 16, and use 2 times 256 and that gives you a 512. So 3 plus 6, that's a 9, plus 2, 11, 1, 1. 1 plus 1, that's a 2, plus another 1, that's a 3, and there you have 531. To prove this, so I've opened up a Google tab, and in this Google tab you can actually see by the website's explanation that 213 in hexadecimal is simply 531 in the denary system. Why is it this? Because simply you have changed the base. You're not using base 10, which is typically used in everyday life. You're using base 16. So that was a simple explanation on what the hexadecimal system is. I hope you've gotten something from this video. Sorry for rushing you through the video. I just wanted you to get a quick glimpse of what the hexadecimal system is before we can actually start converting numbers manually from the denary system to the hexadecimal system. So thanks for watching. Please leave a like and subscribe.